Welcome, guys. I hope you can see the audio and video online. All of you, welcome to the sessions. First, let me explain you what we are going to go through, and then we'll give a quick start. For the next 3 days, we are going to introduce the basics on layers and protocols. Technical subject that we are going to touch is on layers and protocols introduction, because we are going to either become protocol testers and protocol developers. So we have to be really sure about how the protocols behave, what do protocols do, everything related to it. So these are the starting sessions for us to understand protocols. All right. So once we introduce it, the first set of protocols we are going to learn are TCP/IP based protocols. Why? The core subject we are going to learn is LTE, advanced LTE, and IMS and 5G. In all these technologies, IP transport plays a crucial role. IP transport, nothing but IP technology, which plays a crucial role. So definitely to understand LTE, advanced LTE, IMS and 5G in a perfect way, you have to first understand IP technology to a really good level. So that is why we are going to start with IP technology classes at first. Then we'll later move into the telecom technology. Then we start learning LTE, advanced LTE, IMS and 5G. That is how we go about it. To the first few classes, we're going to have a division or a split. There is going to be technical session that we start in a minute. At the end of the technical session, I will spend some time on explaining you the course content and introduce all the lab and the tools that we are going to use as part of this course. I'll start showing you those tools. So if you have any questions at the end of the session or whatever, you can keep asking those questions. So there is a Q&A session at the ending. Whatever the doubts and questions that you might have, you can shoot it. So I'll be able to answer. I'll try to answer as much as I can. So over totally around 9 tools we will be using as part of this training, and we will be introducing 3 tools per day. So today I'll introduce 3 tools, tomorrow I'll introduce 3 tools, and day after I'll introduce 3 tools. That way. So that at the end of these 3 sessions, we'll get introduced to all the tools that we are going to use. So that would be at the ending of the technical session. Now we are going to go ahead with the technical session straight away. So before we going into the technical session, I would like to introduce myself. My name is Banerjee, and I'm having around 16 plus years of experience in telecommunication and data communication technology. Worked entirely, my career is on telecom and datacom part. I know about 120 protocols in total in telecom and datacom world, and I have worked on most of the protocols in the 3GPP area and in datacom area as well. So with that vast amount of experience in this part, whatever the course that you're going to go through, the entirely it is designed by me, and the subject and everything is from my experience, my working experience is like converted into a content based course which can be helpful for you to get into telecom industry. So that is my little introduction, and with that we are ready to go ahead and start with the technical discussion about layers and protocols. Little instruction for online guys. You can keep your mic muted as most of you are already in muted state. If you have any questions you want to ask, you can unmute yourself at any moment in time and you can ask your questions. All right, let's give a start. So what's going to be the future story? Ultimately, you are going to become telecom or datacom protocol tester or developer, one of it. So first question that comes to our mind is how to master this protocol testing or development. Then the next question is how to become a master in telecom datacom protocols. Obviously, the question that leads to is what are these protocols, how they work and all that. So where do we start? So before becoming protocol tester or a developer, that is 3 months down the line, before that we have to start with basic thing. What are these protocols means? How do they work? All that basic part. So let's start at this protocol part is where we are going to start. Obviously, I would like to start with human communications because it is very easy to understand protocols and communications from here. So you might have heard that computer communication mechanisms are implemented in 5 or 7 layers. Have you heard that before anywhere? TCP/IP model is 5 layers and OSI is 7 layers. Like that you would have heard earlier. You see? But first of all, we need to understand what are those layers and all that to understand IP technology correctly. Even before we go to that, we need to first introduce what is the meaning of protocol and what is the meaning of these layers. That we will try to achieve by taking some examples from human communications. So to understand that, first we have to analyze human communications. That's where we are starting. Do you think human communication follow a layered architecture or not? What do you think about human communications? Obviously, I believe that human communication is layered architecture. In fact, we have 2 layers in place. What are those? If you observe, brain is your application layer which generates the information, which will be transferred with the help of a mouth, whatever that is generated in the brain. This mouth is a physical layer which is transferring the information from one place to the other place, one human to another human, in the form of a sound wave. So what will be generated is a sound wave. That sound wave will reach the ears. Basically, I am speaking, you guys are listening. It reached your ears by using sound wave and air interface. That ear sees the other physical interface, physical layer on the receiving side. The mind that is processing the information, the mind that is processing whatever I am speaking, your mind is basically the receiving application. Is going to be your receiving application. You see? So how many layers we have here? My mind and your mind is applications, sending application and receiving application. My mouth and your ears is physical components which are actually transferring the information in the form of a sound wave, voice sound wave. So 2 layers we have. Layers basically defines functionality. What is the layer's functionality here? What is the application layer doing here? Generating the information. My mind is generating information right now. Your mind is processing the information. So generation and receiving of the information and processing of the information is called as application. But what about physical doing here? Transfer. One guy is transferring, the other guy is receiving it, basically capturing it and converting it into meaningful language so that brain can understand. Right? That's our layers. The split is layers for us. Right. Great. We can actually make it bidirectional also by adding ears on either side. Bidirectional, but number of layers are same. Number of layers are same, but it just became bidirectional. That's all. Okay. Communication is bidirectional. Perfect. Human communication in another way. Brain is generating the information, the other brain would like to get that information. But between me and you, I want to transfer some information to you, but between me and you, there is a soundproof glass. So what do I have to do? If there is a soundproof glass between me and you, if I speak, it won't cross that soundproof glass. It won't reach you. You see, I can transfer it. So what do I have to do? I have generated information in my brain, but the physical medium I am going to use should be changing. Because there is a soundproof glass, you can see me. I can actually make actions. You will be able to see my actions with your eyes. Try to understand what I am mimicking. You try to convert that into some form of information. You see? See, information is same, but the way of transferring the information is different in the previous case and in this case. Okay? Here we don't need air. Even in vacuum, I can give you information. Only the thing that is needed is light, because you must see me so that you can see my actions, you can understand what I am trying to convey to you. Now, number of layers changed or not changed? Number of layers are only two: application, physical. But application layer, nothing changed. Physical layer is changed. The way that previous communication occurred is different, and the way this communication occurred is different. So, physical layer functionality is to transfer the information. Previously, we have transferred the information by using sound wave. Now we have transferred the information by using actions and eyes. Right? Now, we have to now here introduce what is the meaning of a protocol. What is the difference between layers and protocols? Layers defines the functionality. Protocol defines methods to achieve functionality. What is the application layer's duty in the previous example? Generation of information. That is a layer which generates the information. But protocol is different. What way you can generate the information? For example, I can generate the information in English language or Hindi language or my local language. I can generate it in multiple languages. If I am speaking in English language, your mind also should possess English language. Then only you can understand whatever I am trying to say. Definitely my voice will reach your ears. Your mind will get it. But your mind won't be able to understand if you don't know English. You see? If English protocol is missing from your mind, brain layer is there, but protocol also should be there. You see? How many protocols can be there in application level? Many. Each language is a protocol. Hindi, English, Italian, German. You see? Each language is a different protocol. If I am speaking in German, started suddenly speaking in German or Mandarin, You will listen to me definitely because your ears are working. Your brain will be able to receive what I am speaking, but your brain will not be able to understand what I am trying to say because you don't have that protocol. You have the layer, but you don't have the protocol. You see? So layer defines the functionality, protocol defines what are the different ways of achieving that functionality. What are the different methods of achieving that functionality? So the ultimate point that you can understand is layers are normally fixed in number, but in every layer there can be many protocols in every layer. Right now in application layer, how many protocols we have? Two. Hindi, English. Two protocols are there. You can add as many protocols as you want. If you keep writing all the worldwide languages, the number will keep increasing, number of but all those languages will be coming under what layer? Only one layer. What is that layer? Brains, application layer. It is. Are we getting it? Physical layer. What does it do? Transfers the information is the definition of the functionality. Physical layer functionality is that. Transfer the information. But what are the different methods we can use to transfer? Sound wave, letter. In the previous example, we have seen actions and eyes. All these are different methods that are available to transfer the information from one unit to another unit. You see? All these are what? Different protocols. The sound wave is a different protocol. Letter is a different protocol. Writing a letter and sending it to the other side. Making actions is one protocol. These are the multiple protocols that are available in the physical layer of human communication. So what's the point? Every layer may contain many protocols, right? We choose a protocol depending on the need. Based on the need, we choose the protocol. What is the need means? I'll explain you. One guy is there at 1 kilometer distance. There is no phone, nothing. You are here, the other person is there. Right? Now you want to talk, you want to send some information to him. You want to tell something to him. You can't shout because your voice won't go there. So what do you need to do? You have to write it in a letter. Maybe give it to some person who is traveling there. That person hands over that letter. He reads it, understands what you are trying to say. Ultimately, information is reaching, but the method is different or not. You see, because the distance is giving a trouble for sending your voice signal, we have chosen which method? Letter method. That means protocols will be picked up based on the need. Every layer may contain many protocols. Let me tell you. In OSI, if there are 7 layers, each and every layer is going to contain maybe hundreds of protocols. You see? But which protocol to be used will be picked up based on the need. A lot of protocols are there in the world. Okay, what those technical protocols we understand later, but I'm just giving you a first-hand understanding on that. Okay, great. Is this clear so far? You understood what is the meaning of differences between layer and protocol? Okay. Where actual functionality is implemented? In protocol or in layer? Layer is very abstract. It never implements anything. Who implements the actual functionality is always protocol. Protocols are part of the layer. But layer never does anything. Layer just defines the functionality, tells that whoever implements this functionality, that guy is great. Who is that guy? Protocol. Actually, the functionality implementer is who? Protocol. Functionality implementer is the protocol, not layer. Layer is only like define it and leave it. That's all. Define the functionality, leave it. Got it? Now, just to understand the layer view versus protocol view, this is the difference. Application layer, application protocol. Application layer is brain, the one that is generating information. What kind of information? English. That is protocol. Differences between layers and protocols. Okay. Physical layer is mouth and ears and mouth. On the other side, what is protocol? English language only, Indian slang. You see, we speak in our own slang, right? That Indian slang is the physical layer mechanism that we speak English, but which way? Indian way. Okay, that is the way that a sound wave is going to be generated. If the other guy is Italian or something who can't understand Indian slang, he won't be able to process your voice information. He'll say pardon, pardon 10 times because you have to reiterate it, slowly speak, and you have to get rid of your slang so that he'll understand. You see, he know English, but he can't understand the slang. You see, so in a protocol view, if any protocol is not working, the entire communication will go for a toss. The other guy knows English, but if it doesn't understand Indian slang, now it's gone for a toss. You have generated English sentences speaking in Indian slang, but if the other guy can't pick up Indian slang, knowing English language is useless. So that means in the layers and protocols, all the protocols at all the components should work to make sure that the communication is complete. You got it? Both the protocols should be same. For example, assume this case. On sending side, receiving side, protocols must be same. Why? If this guy is Indian slang and this guy is Italian slang, both of them are actually speaking English. But if this guy speaks in Italian slang, what happens now? That reaches the ears. But ears will actually give it to brain, but you won't be able to process it because there is an issue in understanding that slang, understanding that sound wave. You see, it won't work out. It doesn't work out sometimes. Got it? So same protocol must be used. If, for example, two different country guys are speaking to each other, they have to get rid of the slang to understand each other. That means they are actually like shifting to a common protocol. What is that? By slowly speaking, you get rid of your slang. Okay, if you speak in a very slow narrative, right? You get rid of the slang so that other person can understand you that way. Doesn't matter whether it is application or any layer. Every layer should have an equal protocol. That's how the whole communication will work out. If you have English here, if this guy doesn't understand English, this is Indian guy only, you are going to a village. You have started speaking in Indian slang English. That guy receives it, but you don't know English. You see? He catches your slang, he understands what you are speaking, but he won't be able to grasp your meaning of that sentence because you don't know English. So all the layers, at all layers, all the protocols must be same in order to make the communication complete that way. Many more protocol views. You can make gesture sign language. You make the signs. Every sine wave has got a meaning. The other guy will see it with the eyes. With the help of the light, he is the medium here, and he will get to understand what is the meaning. If you are writing a Hindi text, that text will be transferred to the other side. Other guy will read it, and then he will understand Hindi. He must be able to understand Hindi. So language is Hindi here. Method of sending is writing and reading with the help of a paper. Okay, you are writing it in the form of a text. Multiple methods, multiple protocols. layers are same number, but protocols can be different depending on the need. This concept we have to take it into our computer communications, because we need to understand our IP communications and computer communications. We go there. So what do we transfer by use between computers is the first question. Assume that human has inputted a text called as hi how are you to a computer. Computer definitely requires a graphical user interface app to read this information. Agree or not? You type something on a GUI app, right? You input that into a GUI app. Now what should happen? This information must be transferred from one computer to other computer so that the other human who is sitting in front of that computer will read this information. Hi, how are you? Let us assume these computers are connected with a electrical cable. Electrical cable. Electrical cable can send different voltages like positive 5 volts, negative 5 volts. But what is the problem? Electrical cable can send voltages. How do you transfer this information called as hi, how are you from one system to another system? Is the question. Now you have typed the text, English text. You want to transfer this English text to the other side. How do you transfer it with a electrical cable that is connected, that is used to connect these two computers? How do you transfer this information? Let us find that out. First, let us map data to voltages. This is a simple way of mapping. 0 is negative voltage, 1 is positive voltage. That means it is very easy to send zeros and ones between computers by altering voltages. If you send a 0, if you want to send a 0, you send a negative voltage to the other computer, he will try to understand it as 0. You send a positive voltage, the other computer will understand it as 1. That means by mapping data to electrical voltages, you can easily send zeros and ones from one system to another system. What is the protocol right now? Binary protocol. What is the binary protocol that is implemented between the computers? What is the binary protocol? Positive voltage is 1, negative voltage is 0. That is the binary protocol implemented between sending computer and receiving computer. But I don't want to transmit ones and zeros. What I want to transmit? Binary bits can be transmitted, no problem at all, on the wire by altering the voltages, positive 5 volts and negative 5 volts. But I don't want to transmit ones and zeros. I want to transmit what? Hi, how are you? That is the text I want to transmit. How do we transmit this text? Hi, how are you? From one system to another system, where I have a limitation of transferring only ones and zeros on an electrical cable. How do I transfer English text? We can use some intelligent methods. What is it? So we can generate a binary code for every English character. If you can find or you can invent a binary code, one different binary code for one English character. Now if you send this binary code to the other side, other guy will be able to convert it into English character. You see, what is the meaning of that? How do we do this? I'll explain. So how to convert characters into binary format? There are multiple methods that are already implemented in the world. One of it is ASCII or UTF-8. What is this ASCII proposes? ASCII proposes this. If you have an English character, for example, H, let us take capital H. Where is that? Here. That's out there. Binary code for capital H is these 8 bits. 0, 1, 0, 1, 000. For every English character, they have put a different binary code. So your keyboard contains lot of characters. For every character, there is a code available now, binary code available. Now, are you getting a sense there here? You type English characters in your keyboard. Every code will be converted. Every English character will be converted into a binary code. We have already having a intelligent mechanism to transfer binary information on the wire by using electrical pulses. Are you visualizing communication now in computers? So what happens now? Simple. First, whatever the human input that is given, hi, comma, space, comma, how, space, or space, you, question mark. These are all the English characters. Every character has got a decimal value and corresponding binary value in the ASCII table. It is already available. So you have written down the binary code for every character. So if you put the total here, the total data to be transported is this much. If you transmit this binary code, if the receiving guy also knows, guys listen here carefully, receiving guy also must know ASCII coding mechanism. He must be able to realize if the receiving guy reads this binary code, he must understand that, hey, this is capital H. He must understand it. So not only sending guy must know the ASCII coding, the receiving guy also must know the ASCII coding. You see? Are you understanding that? So that he can convert it into English format and display it to the human being on the other side. So the total information that human typed is this, converted into binary data. How it will be transported? Let us see. Computers are connected with electrical cable. Human being is inputting the English text, which is read by the GUI application. GUI application's first duty is convert it into what? Binary format that can be transferred. Alright? So, he takes some time and does some work, convert each and every English character into a binary code. After generating the binary code, he will pass that binary code one after the other, bit by bit. He will transfer it to physical layer, which is holding the electrical cable, which is having the electrical cable connected to it. Alright. So what this electrical guy is doing, his logic is very simple. Whenever he sees a 0, he is going to transmit what? A negative electrical pulse. 1 positive electrical pulse. 0 negative. 0 negative. 1 positive. 0 negative. Simple. Bit by bit, the physical guy need to keep converting it into electrical pulses. Positive electrical pulse and negative electrical pulse. The receiving electrical unit receives these electrical pulses. He already knew the protocol. He says that negative electrical pulse means what? 0. Positive means 1. Like that, he will convert it into digital data. That digital data will be forwarded to GUI application, which is present in the receiving computer. What does the GUI application in the receiving computer would do? What does he do? It will convert the binary codes back into English text by following the method. By reading 88 bits, he will convert it into one English character. Once that is done, that will be presented to the human being, that data. How many layers we have? 2 layers. Application, physical. 2 layers we have. All right. How many protocols we have used? Two protocols. What are those? At application level, we are using a protocol called as ASCII, which is a English to binary converting protocol. How to convert English characters into binary data. That protocol is ASCII protocol. So at application level, we are using ASCII protocol, both sides, sending side as well as receiving side. At physical layer level, we are using electrical binary protocol. What is that? Which binary bits? There are only two binary bits, ones and zeros. Which binary bit corresponds to which electrical pulse? 0 is negative electrical pulse, 1 is positive electrical pulse. These two rules is the protocol in the physical level. Only these two rules. Basically, rules are the protocols. For example, previously H is 72 in the ASCII. Now that is a rule or not? Yes. Sending guy, if he wants to send H, he must send binary code equivalent to a value called as 72. Receiving guy, if he receives a binary code which is equivalent to 72, he must understand it as capital H, display it as capital H. If any side the rule is not followed, then communication will break down. So what is the meaning of protocols in another point of view? Protocols are nothing but rules, guys. Okay, set of rules. So ASCII is a set of rules. What rules ASCII defines? How to convert English characters into binary data. What are the rules out there? Those set of rules is nothing but ASCII. What is this electrical binary rule? Which bit is to be transported as which electrical pulse? Okay, listen to this carefully. If this guy wanted to send 0, he transmitted negative electrical pulse. If this guy is understanding that negative electrical pulse as 1, what happens? Wrong, right? All the information that we have sent is going to be reversed on the other side. It is not correct. The receiving guy also must be working on the same rules, same protocol, whatever that is being used on the sending side. Okay. So he must understand negative electrical pulse means not 1. What is it? 0. Same rule that is used as the sender. Great. So we have transported the information from sending computer to receiving computer by using how many layers? 2 layers. You see? How many protocols? 2 protocols. ASCII, binary to electrical conversion protocol. Great. So protocol view, if you see, in real world, how it works out is not direct electrical pulses, positive and negative, but there is something called as clock going on continuously. 0 voltage to positive voltage, that is called as clock. When there is data that need to be transported, if you use famous protocols like Manchester encoding protocols, wherever there is a 1, the signal will move from negative to positive. Half negative voltage, half positive voltage. If it is 0 means positive voltage to negative voltage. Rules are different here. Previously it was a very blind direct forwarding rule. Positive means negative voltage means 0, positive voltage means 1. Here the rule is different. Here if the voltage is moving from negative to positive means 1, positive to negative means 0. Rule is changing. Protocol rules are changing. You see, how to convert binary data into electrical pulses, those rules are changing. This particular rule is called as what? Manchester encoding rules. You got it? That is the protocol name. Okay. 1 means 0, negative to positive. 0 means positive to negative. 1 is negative to positive. Another time 1 means again negative to positive. Every time 1 means it is always negative to positive. 1 means again negative to positive. 0 means positive to negative. Again 0 means positive to negative. It is like that always. Okay. Now what is the protocol view for us? Application protocol is ASCII, used by your GUI application to convert English characters inputted by the human into binary data. Physical layer is using a protocol called as Manchester encoding to convert binary bits into electrical pulses. Which kind of electrical pulses? Either negative to positive electrical pulse or positive to negative electrical pulse, depending on whether it is 1 or 0. That rule is Manchester encoding protocol in the physical level. Same protocol will be used on the receiving side, Manchester encoding protocol. Application layer will use ASCII. Are you understanding the difference between layers and protocols right now? Okay, these are protocols now, not layers. Of course, how many layers we have? 2. Story goes to the next level. Why do computers need 5 or 7 layers? With how many layers we have achieved the functionality in the previous slide? Just 2 layers between 2 computers. Application layer, physical layer. Application layer read the human information, converted into binary. Physical layer sent the information to the other side with the help of electrical pulses. Then why do we need these many layers? Have you understood that question? Very critical question to understand communications. Because we are going to become protocol engineers, you need to understand this. Why do we have to have these many layers when we can just achieve or establish the functionality with just 2 layers? Just like in the previous case, why do we need these many layers? Let me explain you one more point before I ask you this question once again. Except your physical layer, rest of the layers are software based layers. They are all softwares. Only physical layer is half software to have that Manchester encoding rules, which is software. To generate the electrical pulses, it will use a physical electrical functionality, which is mechanical, which is electrical. Basically, that is the only half part is your mechanical section. Remaining half is software based. So how many layers are software based in the total thing? Out of the 7 layers we have, 6.5 layers are software based. Only half a layer is mechanical or your physical actually. That is not software based. Now what is my question? Why do we need to have these many layers if it is software based? Instead of developing 6 different softwares, we can develop one big software which can do all the functionality. First point is this. First of all, why do we need these many layers? What do additional layers do? You go back to the previous thing I have explained you. I have told you that every layer defines functionality is what I have told you. What is the straightforward meaning of having additional layers? Because every layer is defining a functionality. If you are introducing additional layers means additional functionality, right? But I am again contradicting myself. All these functionalities are implemented by using a software. It's all software based layers. All these layers are. Now my question is, if they are all just software based layers, why can't you develop one single big software which can do all these functions, which can achieve all the functionality of all the layers? Why do we need to have these many layers? What is the advantage of having these many layers? Yes. Security? No.
And we don't know what type of device it is using physical. For example, it depends upon it varies from that what type of device. Let's take example like how or what type of things we router, because each and every device will have some different type of mechanism to pass on the data. Maybe
So basic understanding there is simple. We have these many layers because we wanted to have flexibility of choosing which layers we want to skip in different components. We will have that flexibility when you divide this into layers. If you develop it as a single unit, you have to install that single unit everywhere, which is not required. I will explain you in another way. You are writing your letter in Punjabi to a friend who is in Punjab, but you are closing that letter, writing only from address to address on the top of the letter, keeping that into a post dabba. Postman will read that to address and from address, forward that letter to your friend. Who needs to understand Punjabi? Who needs to read that letter? Your friend, not the postman. Postman, if he can understand from address and to address, that is enough. Postman doesn't need to know all the worldwide languages which will be used inside the letters. He doesn't need to know. He only need to be able to read to address from address maximum and forward the letter to make it reach the destination. Now, in computer communications, we have something called as routers. Routers will forward the data with the help of something called as IP addresses. Those IP addresses are added at which layer? At network layer, the IP addresses will be added. Not at application level. The addresses will be added at network layer. Now my point here is this. Router never need to have application layer. Why? No human being sits in front of a router. So router doesn't need to convert the data into English and show it to a human. Router never need to have application. Maximum how many layers are enough for router? 3 layers are enough for router. Network, data link and physical are enough for router to be able to forward the traffic to the next place, to the next unit. Just because he need to read only address part, he doesn't need to worry about what is there inside the content. You see, that means we have divided the whole functionality that is required in computer communications into many layers such that we will have the flexibility to choose which layers we want to implement in which components. We have that flexibility, not because of security or any other reason. It is because we have the flexibility. I will explain you with one more example. This presentation layer will do a functionality called as ciphering. What is the meaning of ciphering? Converting your application data into a secret format. By using your application like Mozilla Firefox, if you are connecting to bank server, definitely presentation layer has to convert this banking information into secret format so that nobody will be in the middle, nobody in the middle will be able to understand that information. We want to send it secretly only to the bank server. But if you are opening a newspaper, you don't need the secret service of the presentation layer. If you doing what? Opening a newspaper portal like timesofindia.com, something like that. For that you don't need presentation layer to convert it into secret format. Why? There is no secrecy there. Anybody can read Times of India newspaper. What is great in it? There is no secrecy required. What is the meaning of it now? Now, if you are opening your bank application, presentation layer is required. When you are opening a newspaper, presentation layer is not required. Now, because presentation layer is designed separately, you can choose to opt out presentation layer when it is not needed. Are you understanding that? You have that flexibility. You can choose that out. You can say, I don't need this because my information is not sensitive information. I don't need presentation layer. Okay. If you go into a hotel room, various requirements for you, right? If you are an ultra billionaire or something, you want a suite or you want one five-star hotel's whole floor as your, your room. You don't want anybody else to enter into that floor because you are a multi-millionaire or multi-billionaire. But if we are normal people, if we wanted to go into a hotel, we'll book based on our sensibilities. What do we want to be comfortable on that particular stay? We don't really care about rest of the things, status, all this. We don't care much. You see, it's like choosing the things, right? So same way here, each and every layer is implementing some X number of functionalities. If you want that functionalities, we keep that layer. Otherwise, we'll tell him that, hey man, take rest. I don't need your functionality. Thank you. We'll have that flexibility. Okay. Otherwise, if you develop it as a single unit, you have to use that everywhere. We don't want that. You got it? So what is it now? Why we have 7 layers? Whatever the functionalities we have introduced in our previous example were not enough. New functionalities are needed. Each and every layer is bringing new functionalities. Like what? Presentation layer bringing secrecy to your data. New functionality it is bringing in. So every layer is bringing in new functionalities. But we have kept multiple layers. These functionalities we have divided into multiple layers and kept it so that we'll have a complete flexibility in choosing which ones we want, which ones we don't want. Got it? Great. Now we are going to introduce to something called as headers. Very crucial. Let's revisit the previous hi, how are you example for this. Human wants to attach date and time along with the input text called as hi, how are you. Date and time. Time is this, date and time is this basically. But human cannot enter date and time, no need to. Even if you enter date and time, date will be correct. But time no, will keep changing, fluctuating, will keep moving. Better if the application attaches the date and time. Agree or not? Instead of human attaching it. No need to human attach. Why? Computer knows its own date and time. We can make the computer also attach the date and time. Why? We don't need to input what is the date to the computer. Computer knows its date and time. You see? So we can tell the application layer that please add the date and time yourself. You see? So better to make the application software add the date and time. Any additional information attached by any protocol at any layer is called as header. Right now, this date and time is going to be a header added by application to beautifully present the data to the receiver to explain him that when this data is generated, additional functionality, additional header, this is called as header. One more additional field is getting attached. You see? But reality is that geo application attaches date and time, that also must be converted into binary format because you cannot transfer anything other than binary format. Hi, how are you is binary format. Date and time input is also binary format. Only difference is, listen to this carefully. Receiving application must be able to understand how much is the header, how much is human input. He must be able to divide that. That means there must be some rules for header. If there are no rules for the header, receiving I can't understand out of the total binary data that is sent, how much is the header attached by application, how much is the human input. It's impossible to receiving application to understand it if there are no rules. That means application can add the header, but only point I am adding additionally is whatever header you want to add, you can add, but there must be rules followed. Okay, the rules must be known to both sending application as well as receiving application. For example, I will set the rule. The date and time can be attached. It will be 20 bytes, assume. Okay, 20 bytes can be attached as the header. Sender knows that date and time must be attached as a 20 byte header. Receiving also must know that header size is how much? 20 bytes. So that the first 20 bytes he will convert it into date and time, display that there. Remaining information he will convert it into English text, display it as human information. You see? But if the sender is sending 20 bytes, header part, receiving is understanding it as 22 bytes or 19 bytes. It is wrong. Why? If he converts into 19 bytes, no, what happens now? 1 byte will be added to human input. Now human input will look wrong. You see, it won't look like hi, how are you? One additional character also will be added there. Why? Why additional character will be added there? Actually, the header that is attached by the application is 20 bytes, but the receiving guy only converted 19 bytes into date and time. 1 byte he added to human input. Now human input is not accurate. Along with hi, how are you, one additional byte will be there, which is going to be understood as human input. That is wrong. Receiving human being will say, what is this nonsense? It should be hi, how are you? You know, before hi, why yes is there? What is the meaning of yes, hi? Okay, this is nonsense. So what is the point here? The sender and receiver must know the header rules. What is the header that is getting attached? What is the size of the header? What are the information that is present in the header? It must be known to the both the guys, sending guy as well as the receiving guy. So every layer will implement the functionality with the help of headers. Every layer will implement the functionality with the help of headers. We see two computers connected with a cable. Human being is inputting the information into application. Alright? That is human input. For that, what application layer is going to do? Application layer definitely have to attach its own header. Agree or not? So that is human input converted into binary data. For that, application is attaching some header in the binary format. But how much header is attached by the application is known to sending application as well as receiving application. Those rules are known to both the guys. How much is that? Getting it? Now this total thing after attaching the header is called as application data, including human input. That will be forwarded to which layer? Presentation. Next layer. 7 layers now we have. What does presentation do? Presentation layer is also doing some functionality or not? Every layer which is doing some functionality will attach some header. Every layer will attach the header. Okay, because they are having some functionality. According to their functionality, they have to attach some header. It is mandatory. You are submitting a application form into government office. 4 officers are working on your application. Everybody will write some comments or not, based on what the observation they have had and everything. So every guy is doing a functionality. Every guy is attaching some information there. Same thing with your headers as well. So every layer will include a header. But listen to this carefully. If presentation layer is attaching some header, sending presentation layer know how much header is attached. Those rules are known to sending presentation layer as well as receiving presentation layer. Agree or not? Now the total information is presentation, sent to session, it will attach the header. Same again, whatever the header session layer will attach, that will be known to the receiving session layer. How much header is there in that? So every guy will do that job. Every layer will be attaching header, okay, and sending it to the lower layers. You see? Physical layer is only the guy who doesn't normally attach any header. He will convert the data into electrical pulses like zeros, negative, ones, positive, like that. It will convert it into electrical pulses and it will transmit that to the receiving side. Receiving physical layer, what is he going to do? Send this data to which layer? Data link layer. What does data link layer need to do? Because he already has the rules about how much header should be attached by sender, he will be able to separate how much is the header, how much is the higher layer information. He will first separate it. He will separate that is my header according to the rules. Remaining thing is not my business. What do I need to do? I need to only deal with my header. I will read my header. Whatever the other guy is telling me, I will understand. I will try to do that functionality. After I complete my after I achieve my functionality, I need to remove my header. I need to forward the remaining information to higher layer, because higher layer information is none of my business. You see, I only take care about my header. My business I will do. What I have to do, the other guy is already telling me in the form of what? Header. That the details are there in the header, what I am supposed to do. I have already done that. I have read that header. I know how much header is there. I have read it. I have done my job. Remaining thing I am forwarding it to higher layer. What does that higher layer called as network layer will do? Same. He will have to find out how much is his header in that. He will split. This is my header. Remaining is none of my business. I will do my job according to whatever my header is telling me. I will forward the remaining thing to higher layer. I should not forward my header to higher layer. Higher layer won't understand. I have to remove that. Forward only the remaining thing to higher layer. So every layer is going to split the header and the higher layer data. They will achieve their functionality with their header. Remaining thing they will keep forwarding it to higher layer. So if you look at it, on the sending side, everybody is attaching the headers. On the receiving side, all the layers will be removing the headers to achieve their respective functionalities. Functionality is implemented with the help of what? Headers in all the layers. Headers contain that logic for the functionalities. Okay. Finally, the remaining data will be presented to human being. That white color data is the one, right? This human being inputted. Okay. Remaining all are headers which are attached for achieving some functionality. After that functionality is achieved, no need of these headers. All of it will be removed. You will only have that. You have received an employment letter. Do you care about the stamps, postal stamps on that? No. You will fatafat open that and read the letter inside. When you have to join, you are eager to join the job. You see? You only care about the internal part of it. All these additional stamps, signs and all that you see on the letter, you don't care. You just ignore it. You see? Are you understanding the headers means? What is header? Lot of information will be there in the header. Different layers will attach different information for doing their functionality. Did I introduce what is the functionality each and every layer is doing? No. But I have already told you that each and every layer is doing some functionality. To achieve that functionality, they need to attach some headers. I will explain you. If you are putting a letter into a normal post dabba, other than from address and to address, nothing else will be there. But if you go into a D2DC center and hand over the letter to them, they will give you a tracking number to your letter. They will tell that go to our website, you can track your letter with this number. Those is number, tracking number is additional detail or not. With the help of it, what you are achieving? Reliability to your letter. Your letter will reach reliably to the destination now. How they are achieving it? By having a tracking number and having a big system implementation in the back end. Now to achieve an additional functionality called as reliability, additional header fields are there or not? What is that header field? Tracking number. So every protocol is doing some functionalities. To achieve that functionality, they need to attach some additional headers. That those headers are going to implement the functionality required. Yes. Every layer will add something to that data to do their own job. Okay. All the sending layers will add it. All the receiving layers will remove it because they have done the job that way. Got it? We don't care right now what is that. That's what it is. Headers and story. This is the full header. In that, it may not be only one field. There can be many fields in it. Like lot of small informations. One field is for one purpose. One information is for one purpose. We don't know what is that. Only that layer will know what is that information. What is the meaning of that. Only that layer knows. Right now I am only introducing it generically in a generic fashion. I am not explaining you any fields here. I am only telling you a story that header can be big. It can be 40 bytes, 80 bytes, 90 bytes. One layer can attach. In that many fields will be there. Okay, that way. The sizes will be, you don't know. We have to learn when we are learning the protocols. What are those sizes and all that? Right now I'm only introducing it. Introducing to the concept called as headers attached by every layer to do their job perfectly. That's all. Nothing else. Okay. Last point that we have to learn. SAP. What is SAP? Service Access Point. Is nothing but the software communication link between two layers. SAP is. SAPs are the internal linking between different protocols present in different layers. Internal linking. One protocol to other protocol. What do SAPs do? Do we learn about SAPs? We see. SAPs work between the protocols of the same system. SAPs are not standardized. SAPs are used for exchanging protocol data with one another, additional parameters and informations that the protocols wanted to talk to each other about. You won't understand any of it is so far until unless we see an example. What is that? I will explain you. Where they are first of all. These are the protocol layers we have. Between every two layers we have a SAP. Service Access Point, which is the software linking between this software and this software. This protocol software and this protocol software, we have the SAP, Service Access Point. What is the use of that? I will show you an example. So there is this layer called as transport layer, which will give some data to network layer to send it to the destination through the SAP. Tell him that, hey man, this is the data, you need to send it to destination computer. Please help me sending it to the destination computer. Which data? This green color data. But transport layer will also tell your network layer that you need to deliver this data to so and so destination IP address. I am giving you that job. You have to deliver it to so and so destination IP address. Please deliver it there. Who attaches destination IP address in its header? Who attaches that? Which layer will attach it? Not transport layer. Destination IP address will be attached in the header by network layer. But network layer don't know what address to be attached as the destination. Network layer is getting that input from which layer? Transport layer. Now transport layer is doing two things. He is requesting a job from network layer, asking him that you need to help me to send this data to so and so computer whose IP address is this. You need to help me. Okay. So he is giving two details to network layer. What are those two details? He is giving the data, binary data, as well as IP address. Without IP address, if transport layer just sends this data to network layer will keep scratching his head. I got binary data, but where do I have to send it? Tell me, where do I have to send it? I don't know. I'm not the boss. I have not generated that information. I don't know where it need to be sent. Please tell me where it needs to be sent. I can send it. I can help you. Can you actually write a letter and put it into a post dabba without writing from address to address? No. If you do it, what happens? Postman will definitely take it and go to post office. Will normally do what? Tear it off. You don't care. Why? There is no address. Very forward. Very send it without address. Same case here. You see? So SAPs are the internal linking between the protocols. They speak to each other by using SAPs. Do we learn SAPs? No. But we need to definitely realize that there is a SAP by using which protocols can communicate with each other. Protocols can exchange lot of internal linking details with each other. Protocols have to achieve the functionality by efficiently communicating with each other. They have to achieve the functionality. How do they communicate with each other? By using what? SAPs. You're understanding it? You need to realize that that is there. Got it? So one other important point I would like to tell you here. This destination IP address is one of the parameter that is attached in the network layer header. One of the parameter, one of the field, one of the header field. There are many header fields in the network layer. One of the header field is destination IP address. Who is giving him that input? Transport layer is giving him that input. You see? Without transport layer giving this input, network layer will never be able to attach that address in its header. It can never attach it. So it needs transport layer help for that. So parameters might be attached by one layer, but that parameter information might be forwarded from another layer. Layers will coordinate with each other, communicate with each other, help each other. In this case, who is helping who? Actually, both are helping each other. How? Transport layer is giving the data to IP layer and asking him to deliver it to the destination. Network layer is definitely going to help him to deliver it to the destination. But for that, network layer requires destination IP address. Who is providing it to him? Transport layer. So transport layer is taking the help from network layer. Transport layer is also helping network layer by giving him what is the destination address. Because without having a destination address, network layer can never perform its functionality called as sending the data to the destination. It cannot perform that functionality. You see, that means if network layer has to achieve the functionality, it needs destination IP address. It requires. You see, for that, who is helping him? Transport layer. You forget about this particular example. We'll master about this when we are learning the protocols deeply. But the concept you need to get, protocols can what? Talk to each other, can coordinate with each other, can achieve the functionality by effectively communicating with each other. They have a lot of dependency on each other, protocols. But that protocol dependency is achieved by using what? SAPs, service access points. Got it? Great. So, what we have learned so far, layers introduced, every layer contains what? Many protocols, and between the protocols we have SAPs to communicate and link between these protocols, right? But out of it, which one we concentrate to learn? Layers are abstract, they are nothing, they just define the functionality. Actual functionality is implemented with the help of within what? Protocols. Protocols, what they have to help each other, that we have to learn. Only they are going to talk to each other by using SAPs. We don't need to much bother about SAPs. What we need to understand is what kind of coordination protocols are going to achieve with each other. That we need to understand when we are learning about protocols. Which protocol will help which protocol, or which protocol will give what kind of information to other protocol to achieve its functionality. We definitely learn that, but we have to keep getting it in your head that that internal communication is happening with SAPs, that's all. But ultimately what we have to learn is not layers, not SAPs. We have to learn protocols. If you learn protocols, how protocols will communicate with each other efficiently and achieve the functionality, we definitely understand automatically layers and SAPs. You see, that is obvious, right? You don't need to exclusively learn them. Got it? So what we are going to introduce in the next sessions, what functions each layer is going to perform, which we didn't study that. We understood that there are 7 layers. Each layer will do some functionality, but we didn't learn what functionalities are implemented in each of these 7 layers. We need to introduce that. Then we need to start learning all our IP famous protocols that are there in IP world. We need to understand that. Okay. These are all the protocols at various layers. These are the layers we have. These are the protocols we have, which we'll be learning. For completing learning these protocols by, sorry, Kartikeya, please mute your mic so you will not face the issue if you mute the mic. Okay. So I hope everything should be fine now. I hope you should be getting it. Oh. Is it clean now? Anyone else is facing the issue, guys, online? Okay. So these are the 7 layers we have. Each layer, what are the famous IP protocols we are going to learn. First, we will be learning these protocols theory-wise. What is that layer's functionality? How do they achieve the functionality? What kind of headers they are going to add? What kind of header fields will be there? How do they achieve that functionality? We learn. Then we do the practicals with it. So what is the first module we have started in our course content? The first module we have started now is by introducing data communications and IP fundamentals. We today started with introducing to data communications, layers and all that. We have introduced it. In first 15 to 20 sessions, we are going to cover these OSI protocols, that are famous in all the layers we'll be learning, and we'll do the practicals with the two tools called as GNS3 and Wireshark. Two tools. So that is GNS3 we use to simulate your IP network, start transferring the information from one node to another node, okay, by connecting those nodes, and by achieving function communication between those components, we will be able to transfer the information from one system to another system. You see, like that, we'll be able to connect the components, transfer the information, and we will be able to capture the traffic. We'll be able to analyze the traffic by using this tool called as Wireshark. So this Wireshark is used for capturing the IP traffic, analyze the protocol information inside that moves from one node to another node. We'll be able to capture it, we'll be able to analyze it between the systems. So these two tools are going to be used from our fourth class onwards. We'll be using this for what purpose? Doing our practicals on OSI. Okay, so all these protocols that we are going to learn, we will be doing corresponding protocols, practicals by using these two tools. One is GNS3 and the second one is Wireshark. Got it, guys? That is Wireshark. After this, what we'll be covering? After this, we start with telecommunication fundamentals like wireless telecom basics and 2G, 2.5G, 3G fundamentals we start with. Maximum 3 to 4 sessions will be there on this. After this, we will be learning LTE. We'll learn everything in LTE. So this is going to be the major module. And actually to learn this major module called as LTE only, we are doing all this fundamental exercise called as learning OSI and learning this wireless communication fundamentals. Our main module is going to be LTE, long-term evolution. Okay, where we have to learn LTE protocols. We have already introduced what is the meaning of protocols. First, we are going to learn OSI protocols to understand IP communications perfectly. But our major concentration of learning the protocols is LTE protocols, not datacom protocols, because we are going to do a job on your LTE protocol development or LTE protocol testing. So we will learn how these LTE protocols function, how they are going to achieve their job, what kind of header fields that will be there, what information they will attach, everything we will understand. In LTE protocols, we study LTE protocols extensively, then learn how to develop them or how to test them. You see, so that is the LTE protocol part. These are the protocols we are going to cover. Once we learn these LTE protocols, then we'll cover advanced LTE protocols as well, including IMS protocols and IMS scenarios. Then we start with actual practicals, LTE practicals. In LTE practicals, for protocol testing, we have two methods of protocol testing: script based, tool based. In script based method, we use a scripting language called as TTCN3 scripting language, okay, which is a mandatory scripting language for us to learn. Mandatory, you cannot escape it. If you wanted to become a protocol tester, you must learn this language called as TTCN3, official scripting language for 3GPP. Okay, how do we know? You go to websites, you will be able to understand it. So you type this TTCN3 in internet, Google, take the first link that pops up, ttcn3.org. You go into it, you will see an organization name here called as ITSI, ITSI stands for European Telecommunication Standard Institute, which is a partner company of 3GPP, third generation partnership project. So this TTCN3 is designed and developed and forced into the market by 3GPP itself. So to test all 3GPP protocols, which we are going to learn called as LTE protocols, the popular and the most widely used scripting language is TTCN3. But to write the scripts, to develop the scripts and to execute the scripts of TTCN3, you have to use one of the tools that are available in the world called as Confirm IQ, TTCN3 Toolbox, LVR Testcast, Pragmative Tester, TT Workbench, or Broadbit. Okay, our T3 tools. Yeah, these are the Titan TTCN3 tool set or Trex. One of these 8 tools you have to use to compile and execute the TTCN3 scripts. These tools are pretty costly, typically not be available in normal standard training centers. It won't be available for you. All these tools. So what's the point? We are going to use a tool called as LVR Testcast. We are going to use a tool, Testcast tool, which is used for execution, right? So this is the third tool I am introducing today. Two tools I have already showed you, GNS3 and Vaishak. The third tool I am introducing is LVR Testcast. Sorry. Should not get it. Okay, not a problem. I'll be able to show you the execution tomorrow. There is a license link got broken, so I won't be able to show. This is the tool by using which you can execute the IMS SIP test cases. You can execute LTE MAC related test cases on the UE side. MAC protocol is LTE MAC protocol, and you will be able to execute all the different kinds of test cases. So these are all the execution test suites that are out there, okay, in the test case tool. All right. I'll show you the execution in tomorrow's session on this tool, just to show you. I won't explain you the execution. I will just show you the sample execution of LTE, one LTE execution, one IMS execution, just to show you that the tool is there and it is working and on which you can execute the test cases. That's all. Just to make sure that you get that confidence that you can actually do the protocol test execution on our tools. That's it. Okay. But I have totally introduced how many tools? I introduced 3 tools. These 2 tools, GNS3 and Vaishak, are free of cost. No need to pay anything for this. You can download it and install it on your PC itself. Okay, but you need to know how to work with that. What I will be doing, I will be teaching you how to work with GNS3, how to work with Vaishak. Okay, no pricing at all for this. So you can install on your PCs and working. Right, all practicals on OSI you will be able to do it in your machine only. You don't require our lab machines. But this test case tool, you will be able to use this tool only by connecting to our lab server, using one of our lab servers. You cannot use it at your home. Okay, now online people will get the credentials to log in into the lab server. Direct guys, you will be able to use the tool here itself. Okay, by having it in the lab, you will be able to execute these test cases. Now, why we are getting this tool? Normally, this is run by only companies, which is pretty expensive, about 6,000 euros. about 6 lakhs is going to be the tool cost. Why we get it? Why do we give it to you? Only companies will buy such kind of expensive tools. Reason is because we are partners with this company. That's why we are getting this tool. Okay, this is a company called as LVR Estonia based in Europe. So we are the training and technology partners for them. We do the trainings and lab setup for all the customers of LVR in India. They have different in different countries. They have different uh, partners. We are the partners in India. So there are two partners in India. Another one is Yashashwani Design Solutions in Bangalore. They don't do any trainings. They are just design resellers. We are the technology and training partners in India for LVR. Because of that reason, we get this tool so that you will be able to practice. Otherwise, we even can't buy you the tool by paying 6 lakhs for 1 month license. You'll never be able to get it. Okay, for sure. But you will, this is the tool that the companies will use. All mobile phone protocol software testing will be done by using TTCN3. All mobile phone protocol software testing projects will use one of these 8 tools. If you learn any one tool, you are eligible for the job and interviews. Any one tool out of the 8 tools that are listed here in TTCN3 organization web page. But all the tools are expensive. Okay, each one normally costs you around 4 to 5 lakhs minimum to minimum. 1 license. All right. So there are going to be lot many more tools which we use. What are the other tools we use? I will introduce another 3 tools in tomorrow's session because I can't show you all the tools in one class. I'll be showing you three tools every day. Today I have showed you 3 tools, but I'll show you the execution on this test cast tomorrow. Okay, so that you will have an understanding on that. Right. Good. Have any questions? So now I am opening this session for question and answers. If you have any general questions or any questions for that matter related to this training, of course, I haven't completed explaining the full course content for telecom protocol testing and telecom protocol development, which I will do in the subsequent classes because we don't have enough time to explain everything because we have already overshot our time. 9:30 is going to be the deadline for us. So I will keep explaining you a certain section of it every day. Okay. So in the coming days also, I'll continue to explain you that part. But meanwhile, every day you can actually speak to me before you complete your registration. You can actually now ask any questions that you have, whatever the doubts and things that you have in your mind, you can speak of it. Online guys, you can unmute yourself and you can ask the questions, or you can type the questions if you have any questions in mind. You can use the chat box. You have a chat box available. If you have any questions related to it, you can ask. Well, I don't worry. You, if you can't understand header, you will definitely understand that meaning of header in the next classes. But only realize that every protocol will add some additional information for doing its functionality. Name of that additional information is called as header. That's all. You only realize that. What is this header? What are the inner details there that will be attached? You will understand it in the subsequent classes. Okay. In tomorrow's class, I will give more elaboration on this header part. Okay. Don't need to worry about that. Yes, you do get it whenever you miss the sessions. Okay. Normally, when you attend the session, If you wanted to attend some important sessions, once again, you can request for the sessions, but you won't get all the recorded sessions. You will be getting the session whenever you miss the classes. You don't need to have any kind of knowledge on any scripting or any coding knowledge. Whatever that is required to make you a telecom protocol tester or protocol developer, we will only be teaching you. We will never expect any kind of knowledge from you at all. I never expect that. That means I am assuming that you don't know anything about any parts of telecom protocol testing, about scripting, about anything. We teach everything from the scratch because we cannot assume anything. Because if I assume that you already know something, other people don't know it. So obviously it is going to give a big headache and problem for us. So I need to keep everybody at the same level. That is why even if some of you know about these protocol basics and all that, we have started with the basics once again so that all of you will come to the same level of understanding before we move further. Yes, we do cover Python, but I will explain you this thing about Python. Listen to this. TTCN3 is a scripting language that can be used to do the protocol testing on LTE radio side, LTE core protocol side, or IMS side. All the three sections protocol testing can be done by using TTCN3. But Python can only be used on LTE core and IMS part. Python cannot be used on LTE radio. Why? LTE radio 3GPP has mandated and told that it is mandatory to use TTCN3. That is why we are having TTCN3 as mandatory scripting language, because most of the jobs available in the protocol testing market is on mobile phone protocol testing, which must require TTCN3 knowledge. That's why we are learning TTCN3 because it's very important. Otherwise, you lose half of the jobs in the market without learning TTCN3. But Python is optional. If you wanted to learn, you have a additional module called as Python plus 5G module. You can join into that module, which is going to cost you 10,000 extra, where basically our base module is 30,000. Python plus 5G module is additional 10,000 going to cost you. That is optional module. Even without Python learning, you can get telecom protocol testing jobs for sure. I'm giving you guarantee on that. But if you wanted to be on the safe zone, if you wanted to learn that, you can join that part. So ultimately we cover both, but you need to join both the modules. Nilima, I'll definitely answer your question tomorrow's class. Technical questions I'll definitely answer in tomorrow's class. Please ask the same question tomorrow. I have kept the session open for non-technical questions now. So we stick to that. Technical part I'll explain for sure.
Sir,
Time of
can we
sessions is
keep
going
this
to be
on
same 8 to
notes?
9:30 in the morning. Okay, every day, 6 days a week, Monday to Saturday. Sunday will not have the session. Sorry.
Can we do practicals on Sunday, sir, using our online lab?
We'll explain about weekends batch part, Aditya, to you. We'll talk to you on that. Anything else? Okay.
In the
Online
weekend on
guys, don't
Sunday.
worry. I'll be able to speak to each one of you separately. I'll speak to you on phone. If you have any sort of questions, I'll be able to talk to you and clarify and give you the required information, whatever that is needed. So please join back the session tomorrow at the same time, 8 o'clock, and we will continue further. and we'll have a technical session, as well as I'll introduce the further tools that we are going to use for LTE protocol testing and development. Okay, so I'll introduce further tools in tomorrow's session. So join back. So if you don't have any pressing questions now, I'm, I'm going to stop this meeting here, and we come back in tomorrow's session. Thank you.